So I'm Supriya Chakrabarty. I'm a professor in physics department here at UMass Lowell, and like to welcome you at the Locust, Lowell Center for Space Science and Technology. And my colleague Chris Mandillo and I were involved in this project, Picture C. It was a balloon experiment that we flew last September.
So hi, I'm Chris Mandillo. I'm a research scientist here at UMass Lowell in the physics department. I primarily work on this project Picture C, which is a balloon-borne observatory for looking at directly imaging exoplanets and exoplanetary material around nearby stars. So we're looking to see dust and debris like our own asteroid belt orbiting nearby stars that are similar to the sun. The experiment we built, Picture C, is a 2-foot, 60-centimeter off-axis telescope feeding an instrument called a coronagraph. That is, its primary job is to block the light of this star, or any star you look at, so that you can see exoplanets or dust around that's orbiting the star. This center body here is, this truss structure is our telescope, and inside that is our coronagraph instrument, and in the back end is where all the electronics are. So this whole gondola is supported through all this cabling up by a balloon that's, when it inflates fully, is 400 feet in diameter. Over here is a more close-in image of the experiment. The front end here is the telescope. This is an off-axis telescope. We have an actuated secondary mirror and the coronagraph, which sits here. That's the instrument. Its job is to block the light of a star so that we could see dust and debris and hopefully planets that orbit that star. And in the back end are a number of counterweights and all the electronics that run the instrument.
Caller one. Caller two.
There we go.
Caller's off. Off the band.
There we go. Good luck, Picture.
Hi, this is John Morris at BoldlyGo. We're down in the lab with all the balloon flight components. The last time we saw Chris next to the assembled balloon payload, that was our previous video, and so now it's kind of disassembled after the flight.
So this is Picture C, spread around the lab. It's all disassembled at this point. We got it back in October and we've taken the whole thing apart. So over here you can see the primary mirror. It's covered up right now, that's why it doesn't look shiny. The telescope assembly and truss are sitting here. This would mount over that primary mirror. And then over on the optical table here are the electronics that run the instrument and the coronagraph instrument itself. So you can see the coronagraph is built on a carbon fiber optical bench. This is 2 feet by 4 feet for scale. And inside here are a lot of optics, mostly mirrors. These are parabolic mirrors that focus light back and forth. There are 4 cameras in here. There's 2 wavefront sensor cameras, there's the main science camera, and then there's this acquisition camera. That gives us a view of the sky when we're trying to get the telescope pointed at our star so that we can see what we're looking at and drop the star down into the coronagraph. There were 2 deformable mirrors that flew inside the coronagraph. This one right here is what we call a low order deformable mirror. This does really high speed but sort of coarse corrections to the wavefront of light to make the telescope appear to be perfectly in focus. And then the second deformable mirror, which is what BoldlyGo supported us to fly in this test flight, is actually being worked on over in this corner of the lab. But during the flight, it sat right here, kind of out of the way, and we just ran the electronics and actuated the mirror during flight for the entire duration to test that it would work. Before we flew, we did a pre-flight calibration of the mirror, and now after it's flown, we're doing the post-flight checkout to make sure all the actuators still work and everything still behaves as it did before we flew. Our grad student, Kuravi, is here doing that calibration. You can see the deformable mirror it's facing away from you right now, so the shiny surface is on the opposite side, but this is the controller that drives it, and then the mirror plugs into the front face of this controller. And this is an interferometer that is used to bounce a beam of light off the front surface of the DM. so that we can measure and see the different actuators poking up and down.
Before the flight, we did a complete sweep of all the actuators just to make sure if all the actuators are working and if all the channels are working of the controller. After the flight, we will do the same and figure out if there were any damaged actuators during the flight, or if there was any change to the DM.
Any space mission, any instrument that will ever want to directly image an exoplanet will require a deformable mirror. These are the most important devices for direct imaging of exoplanets. And so through BoldlyGo funding and support, we were able to take the mirror we're planning to fly in the second flight and attach it in the instrument in a test configuration and be able to test it for the entire night at altitude, and it worked very successfully. So we're very thankful for that, and it will enable us to have much more confidence in the second flight to be able to achieve the science goals.